All right, hello everyone, it's Mr. Crawford here. We're talking today about Integrated Math 2's Practice 6, Square Root and Cube Root Graphs. Starting off, I want you guys to just get a general idea of what the square root function looks like. If f of x is equal to the square root of x, and we have all these x's to plug in, what are the corresponding y values or function values that will go along with each one so that we can then plot here on the coordinate plane? Well, if you try to take -2 and plug it in, the first thing you're going to discover is that the square root of -2 is not possible. You cannot square root a negative number, so you're not going to see a point there. The same is true for -1. Also not going to see a point there. But if you plug in 0, the square root of 0 is just 0. If you plug in 1, the square root of 1 is 1. If you plug in 2, the square root of 2 is actually an irrational number. I just kind of want to show you here on the calculator so we can just kind of get a general idea, and then I'll just start doing them on my own. But if I were to type in the square root of 2, you'll see I get the answer about 1.4. So the square root of 2 is about 1.4. The square root of 3 is about 1.7. The square root of 4 is a perfect square. It actually makes 2, and the square root of 9 is also a perfect square, and that makes 3. If I come over here to the coordinate plane, the first thing you'll notice is that because you can't plug any of these negative x values in, no part of the graph exists on this left-hand side in quadrants 2 and 3. The first point I can draw is 0, 0, then the point 1, 1, then the point 2, 1.4, which would be to the right 2 and up about 1.4, so I'm going to estimate it about right there. 3 and 1.7 to the right 3, a little bit more. 4, 2 would be to the right 4 and up 2. And 9, 3 would be to the right 9 and up 3. And you'll notice that the square root function makes this shape. I like to call that the wave. Well, how about a cube root function? If I need to take the cube root of each of these numbers, what are the corresponding y values that are associated with it? If I take the cube root of -8, for instance, well, a moment ago we discovered that you cannot take the square root of a negative, but you can, however, take the cube root of negative numbers. The cube root of -8 is actually -2, because -2 times -2 times -2, or -2 to the third power, would make -8. The cube root of -1 is -1. Cube root of 0 is 0. The cube root of 1 is 1. The cube root of 2, if I type that in here so you can get an idea, is about 1.3, rounded off. The cube root of 3 is about 1.4. Cube root of 4 is about 1.6. And then I went ahead and just skipped on up to the next perfect cube, which is 8. The cube root of 8 is actually 2. The point -8, -2 would be to the left 8 and down 2. -1, -1 would be left 1, down 1. 0, 0 is the origin. 1, 1 is right 1, up 1. 2 and 1.3, 3 and 1.4, 4 and 1.6. You're getting the idea, just a little bit higher. It's just creeping up slowly. If you go all the way out to 8, you'll finally reach 2. And so the cube root graph kind of makes this shape, like so. So square root function, cube root function when it's graphed. So with that in mind, I just want to see if we can plug in some values into different square root and cube root functions and come up with an answer. If we need to find f of 22 in this function, square root of 22 plus 3 minus 4, I want to make sure you understand that the plus 3 is actually inside or underneath the square root symbol, and the minus 4 is outside. So replacing 22, or substituting it in for x, we end up with this expression. Well, 22 plus 3 under the square root sign is 25. And the square root of 25 is 5. 5 minus 4 ends up giving us 1. So we could say f of 22 equals 1. In the next function, it's a cube root function. I want to plug in 4. I would get the cube root of 2 times 4, then plus 1. 2 times 4 is actually the number 8. The cube root of 8 is 2. And 2 plus 1 is 3. So g of 4 is actually 3. Next function, if I were to plug in 1 here, I would have 3 times the square root of 4 times 1. Notice that this 3 is a big 3 in front that is multiplying like a coefficient and not a cube root or a small 3 up in the corner there. Underneath the square root sign, 4 times 1 is 4. The square root of 4 is actually 2. So we end up with 3 times 2, or 6. Finally, on the front side, to find f of 1,000, if we plug it in here, this fraction would now say the cube root of 1,000 over 2. The cube root of 1,000 is actually a perfect cube. It's actually 10. 10 times 10 times 10 is 1,000. And so 10 divided by 2 would give us the number 5. Right? Tune in to part 2 to look at the back side.